Okay, I am assuming that this is where we left off. This looks vaguely familiar. Good, okay. I thought that was second period. So we made our tree diagram by splitting by age group, which was the first question we asked our sample, and then splitting by whether they vaped or not. And we got 8 possible outcomes, vape and no vape, for each of the 4 age groups. And then the second question said, find the probability that the selected adult vapes. And so we went through our tree diagram and we circled in red all of the outcomes where the person vapes. How do I find the total probability that a random adult vapes? What do I do with those red circles? Adam, good. Because it is a 18 to 24-year-old who vapes, or a 25 to 44-year-old who vapes, or, and we know or means add. So we're going to take those numbers and add them together. Please check that I did my math correctly. Pretty sure I added that correctly. I see some nodding. So we know that P vapes is about 14%, 1463. So the advantages here, we could identify pretty quickly, if I drew this tree without numbers, what all of my possible outcomes are, so I know what my sample space looks like. Assigning numbers to each branch then allows me to find probabilities quickly, because I know if I want the probability of any outcome, I multiply the probabilities along the branches to that outcome. Good. Okay, see some people writing, so I'll give you just a minute. Questions on that tree diagram problem? Lingering questions from yesterday's notes that you didn't get to ask yesterday? No, everybody looks like they're asleep. Okay, I'm going to move on because we made this tree yesterday. If you are behind, I can come back to it later. All right, so we have another example. Is this our last? No, almost our last. So our next example says a computer company makes desktops, laptops, and tablet computers at factories in 2 states, California and Texas. The California factory produces 40% of the company's computers. Texas factory makes the rest. Of the computers made in California, 25% are desktops, 30% are laptops, the rest are tablets. Of those made in Texas, 10% are desktops, 20% are laptops, the rest are tablets. All computers are first shipped to a distribution center in Missouri before being sent out to stores. Suppose we select a computer at random from the distribution center and observe where it was made and whether it is a desktop, laptop, or tablet. And part A says, construct a tree diagram to model this process. So we're going to start building our tree. My first branches in the tree, should they represent state or type of computer? Take a minute to discuss with your team, and we're going to vote. State or type of computer? What's the first branch? Don't judge me. uh, I am allergic to everything on planet Earth, and I am itchy all the time. It is so not funny. Good morning, Elia. All right, do I have a volunteer? Which branch do we do first, state or type of computer? State. Very good. Because we were told, we observed where it was made first and then what type of computer, but also the way they identified those probabilities indicates that that's the way we should do it. First, they told us the breakdown by state, and then in each state, they told us the breakdown by type of computer. And so if that's how they described it in words, that's how I should draw my tree. So we have a split for California and for Texas. And what percentage of the computers are made in California? 0.4. Good. Which means 0.6 must be made in Texas. Very good. Because we know each branch in our tree, those individual branches should add to 1. Good. In the next branch, we're splitting into 3 chunks. So we have desktop, which I'm going to call D. We have laptop, which I'm going to call L. And then we have tablet, which I'll call T. So that I'm not having to write words in my tree diagram because it's going to get messy. So 1, 2, 3. 1, 2, 3. Desktop, laptop, tablet. And then I have to start assigning probabilities to those branches. In California, what percentage of those computers are desktops? 25? Is that what I heard? So 0.25. Okay, and then what percent were laptops? 30, so 0.3. That's 55% of the computers, which means tablets must be 45% of the computers, so that they add to 1. All the computers made in California. Good, we repeat the process. For Texas, what percent of Texas computers are desktops? 10. 0.1. What percent are laptops? 20. 0.2. That's 30%, which means the rest is 70. Good, 0.7. Perfect. California makes more desktops and laptops percentage-wise. Texas makes more tablets percentage-wise. Good. And then it says, find the probability, blah, blah, blah. I know in order to do that, I should find the probability of all 6 of my outcomes. How do I find the probability of those individual outcomes? Who can tell me? If I want the probability of randomly selecting a California desktop, how would I find that? Yes, very good, Jeanette. We multiply down the branch to get to a California desktop. Perfect. So for California desktop, 0.4 times 0.25, which I think is 0.2, but I could be wrong. 0.1, because I know what a quarter is. I just can't do math in the morning. So 0.100, and then we follow that process. So 0.4 times 0.3, 0.12, 0.4 times 0.45 is 1.18. 0.6 times 0.1 is 0.6. 0.6 times 0.2 is 1.2. And then 0.6 times 0.7 is 4.2. Nice, pretty numbers. And they ask us, find the probability the computer is a tablet. I want P tablet. I'm going to go through my tree diagram. I'm going to circle all those outcomes in red. So I'm looking for outcomes that are tablets. I can have a California tablet, or I can have a Texas tablet. So what is the probability that I get a tablet at random? 60, yeah. This should be 0.18 plus 0.42, which is 0.60. Yeah. Good. Good. And then a slightly trickier question. Given that a tablet computer is selected, what is the probability that it was made in California? So I want P California given tablet. I know it's a tablet. What's the likelihood it was in California? And we have a formula for conditional probabilities. How am I going to calculate this? P something over P something. The question is, what? What goes in those P's? Very good. Probability of both over probability of the condition, which is tablet. We have both of those numbers. Where is California and tablet in my tree diagram? $18, yeah. California tablet, that's both. So I know the numerator is 0.18. What's the probability that I select a tablet at random? 0.6. We just found that together. Yeah. Yeah. So 0.18 divided by 0.6. And I get, whoops, why can't I draw today? 0.3. So knowing that it's a tablet, there's a 30% chance it was made in California, 70% chance it was made in Texas. So of my tablets, 30% of them came from California. Yeah. Good. So tree diagrams help us organize information. They're not giving us new information. They're just helping us organize complicated systems. Reminders that when you're working on multiple choice problems, they're not going to ask you to make a tree diagram, but you're allowed scratch paper. This might be the best tool to solve a multiple choice problem. So don't be afraid to draw pictures. to help you make sense of the multiple choice portion of the test. Good. Questions about tree diagrams? No. Okay. All right. When I saw you yesterday, we talked about checking for independence. And remember, independence means that knowing that A happens tells me nothing about B happening. And we had to do a whole bunch of calculations. We had to calculate A, and then A given B, and we had to compare. We had to calculate B and B given A and compare. That was tedious. There is a faster way to do it. If two events are independent, then the probability of both happening. Why does my pen hate me? Is just PA times PB. If they are dependent, that would be PB given A. So one way to check is find PA and B from a tree diagram or a table, yeah, and then multiply A and B together and make sure that those two numbers are equal. If they're not, those events are dependent. If those two things are equal, they are independent. So this is a faster way to do that same check that we did last time. We can check that PA is equal to its conditional A given B, or we can check that PA and B is just A times B. Yeah? Okay, let's try an example, because examples are good for you. Okay, so A and B refer to the setting, and then C is kind of its own little thing. It says, New Jersey Transit claims that its 8 a.m. train from Princeton to New York City has probability 0.9 of arriving on time on a randomly selected day. Assume for now that this claim is true. Find the probability that the train arrives late on Monday, but on time on Tuesday. Late on Monday, on time on Tuesday. So I'm pretty sure that that is P late and on time. We're doing two events in succession. Monday, it's late. Tuesday, it's on time. So, how do I calculate that? Ooh, where'd that 0.1 come from? Very good. If there's a 90% chance it's on time, there's a 10% chance it's late. Assuming that early is not an option. And my assumption is they're lumping early with on time. Good. And that gives us 0.09? Yes. Yeah, I can do that. So there's a 9% chance that it's late one day and on time the next. Good. Next one says, what is the probability that the train arrives late at least once in a 5-day week? Oh, that's gross. That's gross. So I know if it's a 5-day week, that's day 1 and day 2 and day 3 and day 4 and day 5. That's 5 numbers multiplied together. The problem with this question as it's written is, yeah, late at least one day could be I'm late only one day, or I'm late 2 days, or I'm late 3 days, or I'm late 4 days, or I'm late all 5 days. That's a lot of calculations. We're going to use the complement trick. What is the complement to late at least one of the 5 days? Because late at least one day is I'm late 1 day, 2 days, 3 days, 4 days, or 5 days. What's the other option we haven't considered? Late none. Late none. The complement to make the whole sample space is I'm late 0 days. Because out of 5 days, I can be late once, twice, 3 times, 4 times, 5 times, or no times. The complement to this is not late any of the days. So I'm going to do 1 minus not late for any of those 5 days, which is easier to calculate. What's the probability for a single day that we're not late? 0.9. If I'm not late any of the 5 days, it's 0.9 times 0.9 times 0.9 times 0.9 times 0.9. So this is 1 minus, and I'm going to use a math shortcut. If I multiply something by itself 5 times, power of 5, 0.9 to the 5th power. Yeah. And I get 40951. I'm going to round it to 4 decimal places because that's kind of my habit. Did I do that correctly? So if on any random day there's a 90% chance that it's on time, then in a 5-day week, there's about a 41% chance it's going to be on time every day that week. No, I take that back. There's a 41% chance it's going to be late at least once, which means there's a 60% chance it'll be on time every week. That makes more sense. My poor brain is fried today. Okay, last question. Government data shows that 5.4% of adults are full-time college students, and that 37.8% of adults are age 55 or older. If we randomly select an adult, is it true that P, full-time college student, and age 55 or older is just the 2 probabilities multiplied together? Why or why not? So I'm going to give you about 90 seconds in your small groups. I want you to talk to each other to find this. Is it just straight multiplication? Why or why not? Discuss. You brought snacks for your whole team? Oh, that was very nice of you. What kind of snacks are they? Crepes. Oh, that's nice. No, thank you. But thank you for offering. Where did you get those? I will have to look for them next time I go. Are these like?
It was under this. Because I was using it. You were messing with it. No, I was using the blue one, and I put mine back when I was done.
Oh, you were using them to make your tree diagrams all nice and pretty. Oh, nice. I appreciate that. All right, volunteer before I call someone. What are we thinking? Who wants to volunteer? Who's going to share first? Oh, frowny face. Frowny face. Camila, what are you thinking? You think you just multiply? So we have one vote. Why can't I write and talk at the same time? For true? And means multiply. All right, Gabe, what about your group? We agree. Jeanette, what about your group? So you looked at the general multiplication rule? Okay, good. Carl, what about your table? True. Mario, what about your table? You said true. Very good. Caleb, what about your table? I think you said no. Okay, Julian, what about your table? You said true. Kaylee, what about your table? You said no. So the true group was over here. We said that PA and B is just PA times PB. The not true group is saying that PA and B is PA times PB given A. And the difference between those formulas is A and B are independent for the first case. A and B are dependent in the second case. So the question is, using what we know about the real world, is there a connection between full-time college student and age 55 or older? Knowing one, does that give you an idea about what the other is? And my instinct is, yeah, what age group is most likely to be in college full-time? Yeah, that 18 to 24 age group, that just out of high school. It's not that there's not older adults in college, but in our society, it is most common to go to college when you are right out of high school, because that's our natural progression for our ed system. So knowing that you are a full-time college student tells me you are most likely to be young. Yeah? There is a connection in the real world between those variables where if I know one piece of information, I'm likely to know information about the other. And so I am most likely over here. As a note, because this would be an FRQ question, right? Not a multiple choice question. Remember that when they ask you why or why not, a lot of the points are coming from can you explain it, whatever it is that you wrote, using statistical vocabulary appropriately. So if you said this, but you could at least provide some justification for why you thought that in terms of statistic knowledge, you probably get partial credit, right? And the goal on the written response is not 4 out of 4. It's an average of 2 out of 4 for a pass. Yeah. So don't let that you were over here get you down. Just make sure that whatever you say on the FRU, you can back it up. Yeah. Good. Okay. Questions? No. Okay. I'm going to pop 10 minutes on the clock and give you that time to review the 4A through 4C notes. Yeah? Get a good sense of what we've done in this unit so far. And then we will move on to our unit quiz. Yeah. So 10 minutes of review. Please use it wisely.